little videos here on how to succeed in 231. This one is how to create a MIPS instruction from one in assembly language from one of the instructions I gave you in class. So let's see if I can get us started here with, there I am. Okay, hang on, there it goes. So if you recall, goodness, okay, there we go. We had the instruction add $S2 $, I guess I gotta write a little slower, S2 $S3. And if you recall, what that means is this guy here, this S2 plus this S3 are going to get stored in that S2. Okay? So I happen to know that add is an R format instruction. Okay? And when I look either on my green card or in my book as to what an R format instruction does, hang on, I'm trying to change colors here. There we go. Or what it needs, how it lays out. I know that I'm going to need my opcode right here. Okay. And after that, I'm going to need the RS, the RT, the RD, the shift amount, I'm just going to write that as SH for now, and then the function code. Okay. Function code. There we go. All right, so the first thing I do is I go to my green card and I try to figure out what I'm going to need as my opcode for add. And what you end up finding out is it's part of this group here. It has a parentheses 1. Okay? What that means is the opcode is going to be 6 zeros. It doesn't tell you too much. It doesn't tell you exactly what it's going to do. It says it's out of a particular group. Okay? So there's a particular group of instructions. This guy is one of them. So I need to go and find the function code for add. That's in the second column. In that second column on the same side of the sheet, I find that the function code for add, kind of weird, it tells me that it's 20 in hex. That's a 0. And I'm just going to put a little 16 here to remind me that this is in hex, and I'll deal with that in a minute. Okay? Now, it tells me I need next the RS, and I can use 5 bits for that, the RT, 5 bits, and the RD, 5 bits. Well, which is which up here? A couple places you can look. You can sort of get this from the green card if you look on the front side. You can also find it in the back of your book. What I like to do, let me look myself up here, is, green color here, is I like to use the back of the book to remind myself that written like this is my destination. This is my RD. Okay? This is my RS. And this is my RT. So then I'm just going to rearrange them down here for a minute. And I'm going to say what comes next is the RS, which is S2. So I'm just going to put S2 here. I'll figure out what he should be in a minute. I'm getting rid of the $sign just for ease of writing. That's S2. Next is my RT. From this equation, that's S3. So I put the S3 here. Again, I still need to translate that again. And finally, my RD is S2. So I put that here. My shift amount is always 0 because there is no shifting in add instructions, so I'll put a 0 for now. And so now I have this thing laid out, maybe in my first level if you want to think of it this way. All zeros here, S2, S3, S2, 0 for my shift, 2, 0 for my function. All right? Let's go to the next level now and turn this guy into binary. So trying to turn this into binary. This again is simply my 6 zeros. So I'll get all 6 of those there. Next should be S2. Okay? Well, S2 is what numbered register? I can tell from my green card that S2 is 18. That's an 8, but I didn't get my 1. There we go. 18. Register S3, I can kind of figure that out logically, is going to be register 19. Register S2, I've already told you, is 18. Shift amount, still 0. And let's turn this one into binary since we already know what he is in hex. We've only got 6 bits to work with. So I say take the 2, turn it into a 2-bit binary number. Take the 0, turn him into a 4-bit binary number. That'll give me my total of 6 bits that I can use in my function code. So I'm getting close. I've got a lot of this stuff in binary. Okay? Let's come back and turn the 18 into a 5-bit binary number. I know it's 5 bits from the R format. 18 happens to be 1, 0, 0, 1, 0. If you don't know that, you need to do a little extra studying on how binary numbers work. Okay? 19 should be one more than that. 1, 0, 0, 1, 1. 18 again. 1, 0, 0, 1, 0. And this is my shift amount of 5 zeros. Let me throw my 6-bit function code down here on the end. Okay, that's all of them, right? 1, 2, 3, 4, 6. And then let me go ahead and tag on my opcode while I'm up here. And now I have my whole thing in binary, and I'm just about done. Okay? As I mentioned before, I will rarely want to see this number in binary. I normally want to see it in hex, because this is just too easy for each of us to make mistakes. So to take this thing and divide it down into hex, I need to separate into strings of 4. Okay, 1, 2, 3, 4. Here, maybe it's a little nicer if I draw lines like this. 4, 1, 2, 3, 4. 1, 2, 3, 4. There's 1. 1, 2, 3, 4. So I'm just chopping this thing up into 4-bit chunks. Okay? Now I'll translate each one of those into a binary number. 4 zeros is simply a 0 in hex. My next one is 0, 0, 1, 0. That is a 2 in hex. 0, 1, 0, 1, some of you might remember, is a 5, both in hex and binary, so that's nice, or decimal rather. 0, 0, 1, 1 is simply a 3. And again, if this isn't coming quickly to you, you want to go back and review your binary numbers. Find a nice high school rate. 1, 0, 0, 1 is a 9. Okay. All zeros again is a 0. 0, 0, 1, 0 is a 2. And all zeros again is a 0. So this is the 32-bit word that represents the instruction add add S2, S2, S3. That's what this instruction looks like down here in the pink in hex.